In this video, I'm going to teach you how you can compute consumer surplus based only on behavioral data. And let me be more precise about the nature of the exercise. So the idea is that you go and you follow a consumer, and at any price P, let's say at different prices, this price, and that price, you measure how much they demand. So let's say the data tells you that at that price they demanded this much, at that price they demanded that much, and at that price they demanded that much, just for example. Then what you can do is use statistical methods, which by the way are studied in more advanced economics classes in an area of economics called econometrics. And what you do is, based on the data, you can estimate what exactly is the precise functional form of the demand function. So let's say you end up concluding that it looks something like this. For every price, remember this is from this perspective, X star of P, based on the data, leads you to believe and to know that that's what the consumer would demand. Okay, so now you know this. The goal now is I'm going to show you in the rest of the section how to compute consumer surplus, given that you can infer that from the data, even if you never know what the individual's experience utility function is. Now, to do that, we need to define one extra concept, which is the inverse demand function. And the inverse demand function, which we're going to denote as P star of X, is mathematically simply the inverse of that. But more interestingly, it has a nice economic interpretation. It tells you for any X, for any level of demand X, what exactly is the price, let's say in this particular case, that will lead the consumer to buy exactly X, no more, no less. I hope it's very intuitive to everyone that that is going to be given by the same locus of points, and we can basically think of the red curve as this inverse demand function when we look at this locus from this perspective. So now I can show you how we can go from data, from the observed behavior, to the consumer surplus without knowing explicitly what the experience utility function is. And here's the idea. So again, suppose that I have gone through the data and I have concluded that my demand function is this, which, remember, also immediately implies what is the inverse demand function. Okay? We know that from the data. Now, we know from what we have studied before that this locus is also equal to the marginal benefit function. We know that, okay, from the data. And we also know that at any price P, we've seen this before, let's say at that price P, the consumer surplus is that area. That's the consumer surplus that we want to estimate. We have seen this time and time before. Now the question is, how do we estimate that without knowing what the benefit function is, the marginal benefit function, because we don't know the experience utility function? I hope that you're seeing that once you know this, the problem is straightforward, because the consumer surplus of P can be written as the integral, remember this is X star of P, from 0 to X star of P of what? Of the area between that curve and that curve. But what is that curve? It's the inverse demand function. So it's the area between P, the inverse demand function, at X, and the price at which we want to compute the consumer surplus P dx. Now this is a very beautiful formula because this is observable, this is observable, and this is observable even if you don't know the experience utility function. Therefore, you can compute the consumer surplus at a price P as long as you know the demand function, as long as you can observe it from the data, even if you don't know anything about the utility function. Now, if you want an intuition for why this is the case, the intuition is here. Is the fact that this same locus of points that defines the demand function, when you think of it from this perspective, immediately define the inverse demand function when you look at it from this perspective. But as long as the consumer is rational and is maximizing its experience utility function, that inverse demand function is exactly equal to the marginal benefit function. So if you know this, the consumer is revealing to you what that marginal function looks like. So you don't see it directly because you cannot open the head and know what it is, but it's somehow being revealed to you through the behavior of the consumer. Beautiful. I really, every time I teach this, I find it really beautiful. Now, let me be crystal clear about the logic and nature of the exercise in which economists apply these ideas. So the idea in the simpler case will be something like this. So suppose that economists are looking at a particular market, and for a while prices, let's say, have been in this range. So let's say economists have observed these 3 points in the demand function. What they can do, and what they're interested in doing is knowing what will be the demand at this new price. These are the ones that were observed. And what will be the consumer surplus at that new price? Now, what is the nature of the exercise? What economists can do is use the econometric tools to estimate this demand function based on the data, and in some sense that estimation process allow it to extrapolate it to prices that have not been observed before, like this range of new prices. But now, based on this data, it can empirically extrapolate, statistically extrapolate what the demand function will look like. And the idea now is that once you can extrapolate and you know that what the demand function looks like, as we have seen, you can compute the consumer surplus at new prices too. So you can compute the consumer surplus at the new price. That's it. Now the previous case is really straightforward, and it involves just predicting the demand and consumer surplus at a price that had never been observed before. Now what about a more complex exercise like the one that we have seen in previous examples, like what is the effect of introducing a minimum purchase constraint of, say, of 1. Now, economists have to often carry out exercises like that, predict what will be the effect on behavior and consumer surplus of a policy like this. Now, in some cases, and maybe we should call those the hard but not too hard cases, what you can do is the following. So in this particular case, suppose that again we have observed prices P1, P2, and P3. So this is the observe. And based on that, and by the way, we have observed those without any restrictions. Based on that, we estimate what the demand function is at any price, again without any restrictions. Now, from solving the mathematical problem of what the optimal behavior is when we introduce this minimal purchase constraint at a level of 1, we know that the behavior in that case is basically gonna look like you demand this when you become constrained, and otherwise you're here. So we know that X star at the new policy, let's call it theta, for any price just looks like that. So in some sense, in this case, knowing what the empirical function looks like allow us to derive the demand function. And once we know that, also from the same logic, computing the consumer surplus is straightforward. So what I'm trying to tell you here is that in these hard but not too hard cases, extrapolating the behavior from the observed behavior is pretty easy, and then extrapolating to consumer surplus is very easy. Now, the really hard cases is when you don't really know how to map easily from X star of P to the new behavior, and you have to somehow make a much harder prediction. The good news is that, as I'm going to show you in the next video, even those cases can be solved, because based on the observed data, you can back out the preferences, the unobserved utility function, and once you know that, you can solve everything. So even those hard cases can be taken care of. And I will show you that on the next video.